All right, let's talk about one of the most misunderstood, most mythologized tools on the entire internet, the Tor browser. We're going to cut through all the noise today, all the scary headlines, and actually break down how this thing works, who really built it, and why its story is just so full of contradictions. So let's just jump right in. And right here, this is it. This is the whole puzzle of Tor in one sentence. It's this incredible, kind of uncomfortable paradox that sits at the very heart of the entire project. I mean, how on earth can all three of these things be true at the same time? Well, that's what we're here to figure out.
So to really get this, we have to start at the beginning. And the origin of Tor is almost certainly not what you think it is. You see, it wasn't cooked up in some hacker's basement for activists or whistleblowers. Nope, it was built for spies.
Yeah, you're seeing that right. The story starts in 1995 at the U.S. Naval Research Lab. They had a huge problem. Imagine you're a CIA agent in a hostile country, and you need to connect to a server back in the States. Sure, your message might be encrypted, but the connection itself, that digital trail, the metadata, that just screams, hey, I'm a spy over here. They had to find a way to make that connection itself invisible. And this quote from Roger Dingledine, one of Tor's co-creators, just nails the solution. Think about it. If you create a secret network and the only people using it are spies, well, it's not a secret network anymore, is it? To properly hide a spy, you need to hide them in a crowd, a big, noisy, diverse crowd. So they released the code to the public. It wasn't about generosity. It was a tactical necessity. Which brings us right up to today. I mean, just look at who's paying the bills. You've got the U.S. State Department funding Tor so that human rights activists and oppressive regimes can get their stories out safely. And at the very same time, you've got other parts of the government spending millions trying to unmask people who are using that exact same network. It's a real live policy contradiction, and it's happening right out in the open.
Okay, so we know the why. Now for the how. How does this thing actually make you anonymous? In this section, we're going to get into the nuts and bolts. We're going to peel back the layers and see exactly why they call it onion routing. But before we get into the nitty-gritty, you have to understand the main goal. The entire system is built around this one beautiful core principle: separation of knowledge. Just get that in your head. The whole point is to make sure that no single computer in the entire chain knows both who you are and what you're looking at. It's a digital need-to-know basis. So here's how it kicks off. When you fire up Tor Browser, it grabs a list of thousands of volunteer-run servers, or relays, all over the world. Then it picks 3 of them, totally at random, to build a little path. You've got a guard relay, which sees your real IP address but has no idea where you're going. You've got an exit relay, which knows where you're going but has no clue who you are. And smack in the middle, you've got the middle relay, which doesn't know you or your destination.
And here's where the onion magic happens. Before your request even leaves your computer, your browser wraps it in 3 layers of encryption, kind of like those Russian nesting dolls. The innermost layer is locked with a key that only the exit relay has. The middle layer is for the middle relay, and the outermost layer is for the very first relay in the chain, the guard. Then, as your data travels through that circuit, each stop just peels off one single layer. The guard relay gets it, peels off the first layer, and sees where to send it next. The middle relay peels off the second. And finally, the exit relay peels off that last layer, revealing your original request, and sends it to the website, having absolutely no idea where it all started. That right there is separation of knowledge in action. It's pretty brilliant.
Now, this tech is cool for browsing the regular web, but it also unlocks something completely different: services that live only inside the Tor network. This is the technology that powers what many people call the dark web. An onion service is a total game changer because, unlike a normal website where you have to know the server's public IP address, here nobody's address is public. The person visiting the site is anonymous, and the server hosting the site is anonymous. This creates a really tricky problem, right? How do 2 people who don't know each other find one another in the dark without giving away their location?
Well, they do it with this incredibly clever dance called the rendezvous protocol. Just think of it like this. You want to meet a friend secretly, so instead of going to their house, you both pick a totally random, neutral spot, a park bench, let's say. You each take your own secret path to get there, you meet, you talk, and then you leave on your own secret paths. You never have to know where the other person came from. That's exactly how this works. And the security behind these services has gotten way, way stronger over time. The old-school .onion addresses were only 16 characters long and, at least in theory, could be cracked with enough computing power. The new addresses are these massive 56-character monstrosities that use incredibly strong cryptography.
They are, for all practical purposes, unbreakable. It just shows how the network is always evolving to stay ahead. Okay, so if the crypto is that strong, how does anyone using Tor ever get identified? This is where we need to get real. The protocol itself is incredibly robust, but it doesn't operate in a fantasy land. Let's talk about how anonymity is actually broken in the real world. So let's just bust the biggest myth right now. Nobody is cracking Tor. It's not happening. That would be like trying to break into Fort Knox by punching the front door. It's pointless. The real attacks are much smarter. They look for the weak points, the browser you're using, the patterns in your traffic, or, and this is the big one, they just wait for you, the user, to make a simple mistake. These right here are the real deal attack methods. And that first one, traffic correlation, that's the theoretical Achilles heel of the whole system. See, if an adversary is powerful enough to watch traffic entering the Tor network in one part of the world and also watch it leaving in another, they can sometimes match up the timing and size of the data packets to connect the dots. It's incredibly hard to do, but it's the fundamental weakness. And this case study is the perfect example of the most common failure of all, just simple human error. A student made a bomb threat using Tor while connected to the Harvard campus Wi-Fi. Now, Tor hides what you're doing online, but it can't hide the fact that you are using Tor from your local network admin. The FBI didn't need any fancy hacks. They just asked who was connected to Tor at 9 a.m. And there was only one person. Game over. Now, the point of all this isn't to scare you away. It's the opposite. It's to empower you. Because once you understand the real threats, you can actually take steps to protect yourself. So in our last section, let's talk about what you can actually do to use Tor safely. First things first, the security slider inside the browser. It's there for a very good reason. See, JavaScript is probably the single biggest source of vulnerabilities in any web browser. In fact, almost every single major, successful de-anonymization attack against Tor users in history has relied on a JavaScript exploit. Cranking the slider up to safest disables it completely. Sure, it'll break a lot of modern websites, but it's a very real trade-off you need to think about. All right, here's the rapid-fire round. Don't ever maximize the Tor browser window. Why? Because your unique screen resolution can be used to fingerprint you. Don't log in to your real Gmail or Facebook account. I mean, that just completely defeats the purpose, right? And whatever you do, do not install any extra browser add-ons or extensions. Every single one is a potential backdoor. Okay, this is probably the question I hear more than any other, and there is so much bad advice out there. The idea is, hey, I'll use a VPN and Tor to be double safe. It sounds like it makes sense, but what does the Tor project itself have to say about it? And there you have it, straight from the source. For most people, most of the time, they advise against it. And here's why. Using a VPN with Tor doesn't really add more security. It just shifts your trust. You're hiding your Tor use from your internet provider, sure, but now you're just handing all that information over to your VPN company. You're adding another layer of complexity and another company that could potentially betray you. At the end of the day, that's what we have to remember. Tor is just a tool. It's a technology. And like any powerful tool, it doesn't have a moral compass. It's used by journalists in war zones to report the truth. It's used by survivors of domestic violence to seek help. And yes, it is also used by criminals. It is complex, it is paradoxical, and it forces us to confront some really hard questions about what privacy actually is and who truly deserves to have it.